Hi everyone, let's do Leetcode 153, find minimum in rotated sorted array. So this is part of the blind 75 list of questions, and today we're going to solve this problem. So we're given an array of length n and it's sorted, but it has been rotated between 1 and n times. For example, let's say we had this input array and we were to rotate it 4 times. This is what we would get. Actually, let's take a simpler example. So let's say we had 1, 2, and 3. If we rotate it 1 time, we would get 3 goes at the beginning, then we would get 0, and then we would get 1. If we were to rotate it 2 times, we would get 1, 3, 0. So as you can see, the last number becomes the first one, and etc. And if you were to rotate it n times, n is the number of elements we have in this input array. This is what we would get. So we would get the same input array. So what we want to do is to find the minimum. So in this case, if we look at this example array, the minimum is actually, it's 0. In this case, again, it's 0. And we want to do it in log n time. It would be really easy to just traverse through this input array and just find the minimum, but that would take big O of n time. The exercise actually requires big O of log n time. This is gonna be possible using a variation of binary search. So let's start by the example given by Leetcode. So we have this input array and we want to return the minimum. As you can see, this was the original one. So one thing to notice is that the original array is sorted in ascending order. When we rotate it, it's still kind of sorted, but it's divided into 2 parts, a right part and a left part. How could we solve this? As I said, we are going to use a variation of binary search. Okay, let's go through the algorithm we're going to use to solve this problem. So in binary search, we have 2 pointers, a left pointer and a right pointer. In this case, we're gonna need a variable result where we're gonna save the minimum. So when we're gonna start our algorithm, we're gonna start this result variable with an arbitrary value, which in this case, I'm gonna use the first value in the input array. Next thing we want to do is at each iteration, we want to check is the value at pointer L smaller than the value at pointer right. If it is, it means that the portion we are actually evaluating is sorted, and what that means is that the left is the smallest value in our array, so we can simply just update our result with whatever the minimum is going to be and return that result. So let me actually explain this a little bit better. So let's say we had this simple input array. The first iteration, we're gonna have left here, right here. When you're gonna enter the first condition of our code, we're gonna check is left smaller than right. Yes, it is. As you can see, this is already sorted. We're simply gonna update our result with the minimum, which in this case is already going to be 1. And we are going to return. Let's actually go through our example. So the first thing we're gonna do is check is left smaller than right. In this case, it's not. So let's go to the binary search. What we do in binary search is we actually find the middle pointer. The middle pointer in this case is gonna be here. Now, we want to evaluate this value. We want to check is this smaller than the current result. No, it's not in this case. This is where the difference comes with binary search. Now we're going to check if nums at position m is greater or equal to nums of L. It means that the m, the middle value, is actually in the left part of this sorted array. So what that means is that this part here up until middle pointer is already sorted, so we can actually eliminate this from evaluation and just look on the right portion. What we will need to do is to update our left to be, so actually what we're gonna do is look right, which translated into code is gonna be L equal to m plus 1. Our L is gonna move all the way here, this is gonna be eliminated. So now in this case, we're gonna go to the next iteration and we're gonna check, is left smaller than R? Yes, it is, because this part is now sorted, and we're going to check, is it smaller than the result so far? Yes, it is. We're going to update the result, and then we're simply going to break out of the while loop. Let's look at another example with the same input array, but with a different rotation. Okay, let's say we had this rotation. What we're gonna do is, again, have a left pointer, right pointer, check. Is left smaller than R? No, it's not. So let's carry on and calculate our middle value. So our result so far, again, I'm gonna start from 2. Is middle smaller than the result so far? No, it's not. Let's check our condition. Is L smaller or equal to the value of pointer M? Yes, it is. So we can eliminate all this part from evaluation. We're gonna move L here. Now, is L smaller than R? It's not. So we need to have a middle value. So our middle will be here. Is middle smaller than result? No, it's not. Is middle greater than the left or equal? So left is still, it's 5 as well. Middle is 5. We are gonna look right. And when we're gonna reach this value, this is where the middle is gonna be. And we're gonna update our result with 1. Left is gonna be here as well, right as well. And this is how we'll find result. Again, as we can see, the result is the same. It's not gonna change. What we're missing here is, in this condition, is an else statement. So we know that we're gonna look right if this statement is going to be true. But if this is not true, we're gonna look at the opposite side. So look left. And we're going to actually update our right pointer to be m-1. So let's look at an example where we're gonna encounter this case. Let's use the same array as before. Okay, so what we want to do is have a result variable. We're gonna start it at 5. Now we're gonna have 2 pointers, left and right. Is left smaller than right? No, it's not. So let's calculate the middle value, which is gonna be here. Is middle smaller than the result? Yes, it is. So we're gonna update our result to 2. We're gonna have a look at these conditions. Is M greater or equal to L? In this case, it's not. If that's the case, we know that whatever is at the right here is gonna be greater than the middle pointer so far. So there is no point in evaluating this one. We are actually going to update our right pointer to be m-1. So right will now be here. And then again, we do the same algorithm. And eventually we're gonna find that our minimum is 1. So the main thing we're gonna need for our algorithm is this piece of code here. The time complexity of this algorithm is big O of log n. Memory is a constant. We are not using anything else apart from pointer, so it's big O of 1. I hope this was clear. It's quite simple. I think you are gonna get a better understanding if you look at the code. Okay, let's try some code now. So the first thing we need is a result variable, which we're going to initialize at an arbitrary value from the input array. I'm just going to initialize it at the first value. The next thing we need are 2 pointers, left and right. Left is going to start at the beginning and the right is going to start at the end of the input array. So we need our main while loop. So while left is going to be smaller than R. This is what we want to do. If the current portion is already sorted, so which means if nums of L is smaller than nums of R, we want to update our result to be the minimum between the result and nums of L. If this condition is true, we want to calculate the new result and just break out of the while loop. Otherwise, we're going to do the actual binary search part. So we're going to calculate our middle point, which is left plus right minus L. So we're calculating the middle this way because in some programming languages you might face arithmetic overflow. So I'm just gonna write it this way even in Python. Okay, so we have the middle pointer. We want to check if this middle pointer is the new minimum. So we'll do minimum of result and nums of m. And then we're going to check if nums of m is greater or equal to nums of l. So if the value at pointer m is greater than the value at pointer l, we are going to search at the right part of the remaining input. Otherwise, we're going to update our right pointer and look at the left part of the array. Once we get out of this while loop, we can simply return our result variable, and it's going to contain the minimum value. So let's see if this works. As you can see, it does work. If you found this video useful, please like and subscribe. Also check out my YouTube channel. You're gonna find many more Leetcode questions and other videos that I hope you're gonna find useful to prepare for your technical interviews. Thank you.